last video, we have proved that this gaming PC can run AI. But some of you guys have pointed out that it was only partially using my GPU. So today we're going to answer the real question in mind. How much AI can this PC really handle before it gives up? And today we're going to answer that question. Hey, what's up, my fellow YouTubers? PC Gaming Dude back in the building today, and today we're going to talk about the very question that is the same title of the video, and that is how much AI can a 4GB GPU actually handle? Now, if you recall in last video, we have talked about that there's a 1050 GeForce Ti that the computer is currently running on right now. And I kind of just gave a brief insight to what Ollama does with AI. Like, how does Ollama run on the computer? And, like I said, just a brief insight, really nothing truly special, just breaking the ground there. And so, today, I'm going to create ourselves a little challenge for this computer. So, we got 4 different models we're going to try running on here. And I'm going to talk about it each as we go. And we're going to go from smooth, we're going to start to push it, we're going to stretch it, and we'll try to get to the breaking point. Just to really see what we got going on over here. Basically call this a little science experiment. And for any of you guys out there that have this very similar setup, 1050 Ti or, 8 gigabytes RAM run on DDR4, for example, this video is just for you. Otherwise, all of you other guys out there can take notes and obviously just adjust it to how your computer is set up. And obviously, we'll keep score. We'll just make sure that, like I said, we keep up with the score there and just see where we go from here. And with that, let's get started. And so for today's experiment, we're going to go ahead and go play around with something called LM Studio. Now, Ollama is a good option, but LM Studio, I apparently done some research, you can find a lot more models than just Ollama. So Ollama's just breaking the ground. LM Studio, we're going to really look into a bunch of models for us to play around with. And so this is Bionic. Nothing too special here, just agentic power at your fingertips, blah, 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 All that sounds a little boring. Let's see here. So we're going to go into setup right here. Only for me. I don't want anybody else using this computer for obvious reasons. Space required. Yeah, we're good. Alright. So we're just going to install Bionic. It is kind of a little bit smaller than Ollama, it seemed like. I think it only required 2 gigabytes. I don't remember how much Ollama needed, but it doesn't need that much at all. And with that in mind, we're going to use 4 different kinds of models, specifically for LM Studio. If you want to know what each of them are, I'll tell you right now. And if you're in that route, listen carefully. So we got Llama 3.2 3B Instruct. That's level number 1. Level 2, we got Quant 3 4B. That's number 2. Number 3 is Llama 3.1 3.2 8B. And level 4 is a 14B class model, which is basically the top of the line there. Now, I'm sure all of you guys will remember that we have the GeForce GTX 1050 Ti, so we're just going to play around with it some. Really push it to its breaking point. And for those tech nerds out there that are wondering, is all this quantized? 100%. That's the only real way we can actually conduct this experiment. It's a lot harder to run this experiment if it's not all quantized, so we'll just play around with that as well. Now, I have also taken notes on here on, let's see here, I got LM Studio downloaded here, got the Bionic documents code natively local, frontier open models, built for privacy. Cool. So supposedly there's a Discover tab. I'm trying to see where it is. Because I want this quantized. Or maybe it already is. I'm not 100% sure. I've never used Bionic before. And if you guys have used it, let me know in the comments down below. So, choose a model. We'll use local models first. And the first one that I'm going to have us use is Llama. Llama 3.23b. So it kind of looks like this one right here. But I'm just going to type it fully in just to see what we're going to play around with. Okay, so 3.2, 3b. Oh, GGUF. That's important. That lets you know, guys, that's your quantized. That is something that I did not really think about till just a second ago. I don't know what GGUF exactly means, but short terms, it's quantized, it's restricted. That's also what quantized means. It's a restricted kind of model, so we could properly run our tests. So this is what we're going to use right here. And we also have uncensored. What does that mean? Shit. Oh, excuse my French, ladies and gentlemen. I do have a foul mouth when I'm not on camera, but... So we're going to let that download. I'm going to take a quick break, and we're going to kick things off once this gets done. This is going to take a minute. Alrighty, ladies and gentlemen. So, it appears that Llama 3.23b, our level 1, has successfully been downloaded. So we're going to go ahead and get started using it in a new chat here. So we got this currently up right now, and like I said earlier, this is the easiest one to run on here. And I currently also have a stopwatch going, or will go. So why do we have a stopwatch for something like this? It's because we're going to try to record the time of the first token. Now, if you guys don't know what token is, it's just basically the first word that pops up on here. We'll try to measure the tokens per second, and then I also have the GPU Z up and running here to like kind of determine VRAM usage and try to figure out if its utilization is pretty good. And so we're going to begin with a prompt. That prompt will be, build me a $1,000 gaming PC. Boy, I wish I was that rich. So the expected result we're trying to think about here is, this is obviously the most useful thing on the whole system. So with that, we'll go ahead and go push it up. It's working. Timer set. 10 seconds in. Do, 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 do. 20 seconds in, and this thing's still trying to work on its first token. This is not looking good, guys. I don't know if we'll be able to get to level 4, to be honest with you. And internet is actually up and running right now, too, so. Oh, yeah. I guess while we got that up and running there. So, the reason why we've done the $1,000 gaming PC as a prompt is because this is going to really take a moment for the AI to kind of like consider everything. All the parts, all the accessories, power supplies, motherboards, GPUs, obviously. It really is looking. Oh, here we go. 1 minute and 17 seconds. And we're doing roughly about 4 tokens a second. That's what it looks like. This was not the correct response, since I need to provide a Python code that creates a $1,000 GamingPC. Here's the corrected response. So, in other words, this thing just gave me a huge middle finger, because they're like, wait, we don't have a Python code. Python, obviously, I'm sure, is crucial in AI technology too, so. Run Python, and how we came up to this prompt here. Alright, so this is all the Python code here. So we got invalid type, expected array, receive string, all the usual Python work. Well, it ran the Python code again. That's what it looks like. And obviously, you can't really edit the Python code, nor do I know how to. That's something else I'm going to try to learn in another video if it does come up to mind. How to work Python. I need to learn how to work on that. So it seems to be running. It's trying to run Python so many times over here, and they're like, I think this might be an epic fail, says the system in mind. I don't know. This is rather interesting. Oh, here we are. Allow LM Studio to download this file. Yes. That's what we're looking at. So, I really decided to stop timing after running the Python, but this is roughly going about 3 minutes or so. 3-4 minutes. Just, this is crazy. But build your own $1,000. It took source from AMD, which, if anyone wanted to know my honest opinion here, AMD is quite frankly one of my favorite graphics units of all time. I knew people that had the Ryzen, which is basically about the same as like a 3050 or 3060 graphics card there, and it is absolutely insane. Allow to download again. Yes. Perhaps. Why did it fail the first time? Oh, the download timed out. I'm not sure my internet's working. Yeah, internet's working. I don't know what's wrong with this thing. This is rather quite interesting. So, Lordy. I don't know how I'm going to rank the latter ones, especially Quen 34B. Yeah. I don't know, ladies and gentlemen. This is not looking good. And with that, I guess we'll go ahead and proceed to move on to Quen to see if we get any better, but I think really it's just, allow LM Studio to download another file. Oh, Lord. This is getting to the verge of diabolical, I will admit. You would think Llama would be good on this thing, but I guess not. So, how are we going to score the first token? This is not very fast at all for this setup that I got. The tokens per second is okay. I mean, we're looking at about 4 tokens a second when it was up on that very first one right there. So, what's the verdict? do we want to use this on a daily use? Well, if it wants you to download several things like this, I don't know if it's just the prompt that I typed in or whatever, but this is also the instruct, yeah, so I'm going to consider that no. And it called 9 tools, and alright. So I guess with that in mind, we'll go ahead and go on to the next one. Alrighty, before we get on to Quinn there, I should note that the GPU load, while we're doing this, is between like 8 and 64%. So it ran export scratchpad file. So it is taking a lot of GPU load. And so this is clock, temperature, fan speed. Yeah. So this is just everything that we got here. And safe to say, I don't really like Llama at all. Now, we're going to switch over to Qwen 34B. This is also the GGUF. Everything downloaded here is GGUF, just for the record. So we're going to ask it the very same prompt. Build me a $1,000 GamingPC. Once again, I got a stopwatch rolling. So we're going to do now. There we go. Working. Alrighty. 10 seconds in. GPU load is almost max right here. So we're looking at about 93%, 99% in some cases. So this is really definitely taking some working. And once everything is popped up right here, we're going to ask ourselves these more questions. Is it smarter? Is it slower? Is it still enjoyable to use? We'll figure that out here in a moment. But memory used is 3,000. Oh, here we go. We got ourselves a clue here. It's reasoning. 50 seconds in. We're about a minute in now. What does the reasoning come out to? Let's find out. Reasoning. Minute and 20 seconds in. This is getting hilarious at this point. And I think I mentioned in the last video that on the cloud models, this seems to be working out fine, but not on the local models that Olama had. Gee, minimum 50 seconds it had to take to reason in. That is rather pathetic. So wait times, obviously, no bueno. And let me see here. So, Llama 3.1, Erebos 3.2, that's number 3 right there. Interestingly enough, they're all by the same, like, little, I guess, name of the model brand. Llama in this case. The last one, which is the Namatron A14B or whatever, that's roughly taking about 45 minutes to install from currently right now, so yeah. If anything happens, I guess I'll let you know. So I never really thought of this here. When it's under this quote-unquote reasoning, it seems to only be doing like 1 token a second. So obviously it's a lot smarter than the very first one, level 1. So this is level 2 right here. Let's try to figure out how to build a $1,000 gaming PC. The user has tried Python code to generate presentation or document but kept getting errors. Then they tried to download some pages from websites like AMD and Greetings, but the downloads timed out or failed because the file wasn't found. Now they're asking again for a $1,000 gaming PC build. So Basically, this whole thing is trying to reason on what I typed. So, at least this part over here is what we're looking at here. Gaming PC under $1,000 requires choosing cost-effective components. So, like, obviously, CPU, GPU, motherboard, RAM, storage, case, power supply, cooling. For the CPU, AMD Ryzen 5 5600X, $150. Not bad. The GPU could be RX 6600 XT for $250. A B550 from Asus or MSI, $70. 16GB DDR4 RAM is about $50. An NVMe SSD like Samsung 980 Pro for $60. Mid-tier like the Corsair VA300 for $50. A 550 watt PSU from Cooler Master for $40. A stock cooler is around $20 there. Totals up to $640, which is under $1,000. So there's $360 left for upgrades or additional components like a better cooler, more RAM, or a better case. Alternatively, maybe the user wants a specific build list from a trusted source. But yeah, you can read the rest if you like. I'm not going to try doing so. I'm just going to get straight to the jump here. Is it smarter? A whole lot smarter. Is it slower? 100%. Is it still enjoyable to use? Well, if you can get past the slow 1 token a second over here, sure. But overall, I think Gwen is a little bit better than having to call 11 tools over here. Now let's jump to the next. It's time to jump to the 3.1 over here. Alright, so now it has finally done something other than the quote-unquote reasoning. And now, with that in mind, we're going to answer the same prompt with Llama 3.1 Erebos 3.2 AB. So we're going to ask it the same prompt here. Build me a $1,000 gaming PC. And before I click enter here, we're going to talk about what we're going to see here for you guys. This is where everything gets interesting. We're starting to stretch the GPU. You'll see a partial GPU offload. System RAM usage is increasing. Slower first token times, obviously, and lower tokens a second. This directly ties into one of the comments I received by the same guy, Bill KSE. Hello, welcome back. About partial GPU offload. So, with that in mind, let's go ahead and go click on this here. And once again, I have a timer going. So, it's working, and working. Timer's still going, but the camera will be off. Alright guys, so after a minute and 25 seconds, we came up with an answer over here, and not with just reasoning. So, there's an alternative $1,000 gaming PC build with components sourced from various retailers. Now, as you can tell, we're only doing like less than a token a second, so obviously, tokens a second is a little bit slower, but if you can get around it, this one's okay. And it jumps straight to an answer without reasoning. Cool. This thing's actually not bad. And actually, the list out is CPU, GPU, 3060 Ti. This is that $1,000 gaming PC. So it wants us to use an i5 12600K. Mine's is A500. RTX 3060. And then we got the cores there. Oh, we over here just managed to jump into red. I wonder what happened there. But, this is not bad. I kind of like it that the 3.1 all of a sudden just jumped to a conclusion without trying to reason for 9 minutes. This is actually a little bit faster, I will admit. For some reason. Like, jump to an answer much more quickly. And we're 3 minutes in, and this is obviously what's going to type out. I mean, no surprise, duh. But if I had to give a score over here, which one is better? Well, the Llama 3.2 that I mentioned about earlier. 3B Instruct. No, absolutely not. I don't recommend that. It's supposed to be the fastest, but not really. Then we go on to the Quen 34B. It reasoned, but it took a long time for this very same prompt. But it gave off answers, so it's a little better. And now we're on to Llama 3.1. It jumps straight to an answer, but the thread tokens are like around or a little less than 1 token a second, so it's a little slow. And while we're at it, we're also looking at the GPU Z over here. It was at one point maxing out the GPU load, so that part kind of made me get a little concerned for the very last one that we got. But yeah, see, memory usage. This is almost 96%, 97%. So the memory use is definitely almost maxing out the memory. So that's pretty serious to think about too. The system memory used, it's definitely going up to like 7100, over 7100. That's just what I noted there. Anyway, I'm going to stop this, and we are going to go skip on to the 14B, the class model. Now, the goal obviously is not necessarily to succeed. We're going to answer this question. This is the grand old question we've been asking for. What happens when a 4 gigabyte GPU tries something that is way too big? I even had the little message pop up and let me know that it's too big. We're about to find this out right now. Possible outcomes: very, very slow generation, mostly CPU and RAM processing, and just failure to load. These are all useful results. So we're going to answer that very last question that we got here, and we'll go from here. Working. And once again, timer is going on right now. And if anything happens, obviously I will come back to it. And with that, there's that. Okay, so here's me trying to do this whole GPU thing, maxing out. I don't know if you guys could tell, but the computer is really struggling to even bother keeping up what's going on here. Everything's starting to freeze up a little bit. I don't know if you guys could read the CPU. I don't know if it's currently up to exacting specs at the moment, but this is actually getting a little concerning trying to run this thing. Consider encoding overload. Consider turning down video settings or use a faster encoding preset. That is not a very good sign here. So now we know what the computer cannot necessarily process here. We have now officially figured out our whole baseline here. So for sakes of I do not want to kill the GPU right away, I'm going to try to end this quickly here. However, I'm not going to be able to really get to it. Okay, so there we are. I just now need to hover over this right here, press that interrupt button, and even have that warning light. This is all for the name of science, but I don't want to kill this computer yet. Alright, so I don't know if you guys can hear in the background here too, but the GPU and the fan is really whirling right now just to stay cool. The temperature might have been absolute bonkers. But it looks like it's kind of slowing down a little bit. Like, it's really trying to just piece out everything together. There we go. It's interrupted. Our computer has been saved. Boy, that was a whole lot of fun. And then this here is the scorecard that I have kept up for this whole little project here. Now, Llama 3.23 bytes. Time for the first token was around minute 17, as said in the video. Then we have 4 tokens a second. Don't really use a whole lot of VRAM. Now, as you can see, the Quantum 3.4 will definitely use a little bit more VRAM. The tokens per second definitely start going down some there. And this is ETA around for the first token there. Llama 3.1, well, a couple more seconds, but, at a cost of half a token, roughly. The VRAM 99% here, and the usage here, holy cow, well, yeah. This 14B class model that we done, just absolute joke, and yeah, so that is the total scorecard of what I kept up for this whole thing. I'm going to say this to you all. This really feels like trying to play a modern game with graphics settings higher than the GPU can really handle. So like Call of Duty Black Ops 7, try playing on this thing. That's kind of like what this feels like. So we're using AI to kind of really build ourselves a little background here to see how the PC can truly handle those higher games. It still runs, but performance drops really fast. And honestly, I really don't want to think about it too much anymore. Now, what should I do next here for you guys? Should I upgrade the GPU and run this test again? If so, what card should I try next? What do you all recommend? And furthermore, let me know in the comments down below if you have any other options, any other tech challenges, stuff like that you want me to play around with next. And with that concludes today's video. I hope that I've covered everything here. I hope it was fun for you all while I'm over here enduring and struggling in pain. And with that in mind, please make sure you all subscribe, like this video, and like I said, don't forget the comments down below. And with that in mind, thank you all for watching, and I will see you all next time. Take care.